Count.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Good morning. I'm Matthew Sutherland.
And I'm Anna Bathgate.
And today we're going to talk to you about cafeteria line modeling and analysis.
Now, we're both from Bloomington, California, in Bloomington. I teach everything from pre-algebra to pre-calculus, although this next year I'll be focusing on pre-algebra and algebra 1.
And I teach pre-algebra and geometry, but this next year I get to teach pre-algebra and geometry honors.
Now, we are lucky enough to be partnered with our mentor, NASA engineer Martin Steele. His area of focus is in system performance analysis and queuing systems. He wants to see what's the probability of launches going off in a year. You know, if you have 8 launches, what's the probability? Or is it better if you have 3 launches? And he wants to see what could be holding up that system for the launches and causing those delays.
And working with Martin, we needed to figure out how to take his research area and to put it into our lesson. And specifically for us, a pre-algebra lesson, but something that could be adapted to Algebra 1 and Algebra 2. So in looking at that, we noticed that Martin works with statistics. Let's go ahead and take a look at what statistics is on a base level.
Now, this is going to be a basic statistics lesson. We're working with pre-algebra kids. We don't want to overwhelm them. We want to make sure we keep it on a level that gets them interested, but just teaches them the foundations of the material.
To have students go through and collect this data, we're going to have them collect specific data that's to them. Their cafeteria, we want to analyze the data and propose a justified solution. By proposing a justified solution, that's something that's viable and that they can actually go through and make sense out of, using these statistics that we're going to talk about. So let's go ahead and take a look at the model that we've created in order to illustrate this cafeteria design that we want the students to look at.
Okay, so I want you to be able to see, I'm going to come up here in front of the model and be able to show you the different parts of it. Okay, right here we have the door into the cafeteria. Now, in the center here, we actually have the cash register. Okay, this is where the students will be checking out for food. And finally, on the end over here, we have where they'll be leaving. What I want you to check for is little green triangles. These green triangles are going to represent the students and the students going through the lunch line. So I'm going to play this simulation for you right now. Okay. Now I want you to notice, right down here, we had a lot of buildup. Right back here, we had a lot of buildup. So what this means, we had so many people coming in that they were having to wait in line to just get in line to check out for food. So this isn't ideal. This is why kids are late to class. So we wanted to have our students come up with proposed solutions to this problem. There shouldn't be more kids coming in than are leaving the cafeteria. All right, so
Going back to the PowerPoint, we need to address standards. We all are held accountable as teachers to teach these students 2 standards, and specifically 3 types of standards. Usually it's your state standards, your national standards, and your Common Core standards. So what we wanted to do is we wanted to give you a little sampling of the standards that we're hitting on. So specifically looking in California, they're going to know definitions about mean, median, and mode, and what that does. The national standards takes it to the next level where they have to look at conjectures and formulate new questions based on things that they see. It kind of gets them to have that deeper level thinking. The Common Core standards would like the students to be able to represent the data with actual visuals. So it's taking the whole modeling process that we've done, looking at it, having them think about it, and then giving a visual to it. So all different modalities of learning are kind of covered. So again, these are kind of just a sample of the standards that we've chosen, just because a lot of them seem to kind of reword the same thing and we didn't want to be redundant.
now, the classes we're covering here is anything from 7th to 10th grade pre-algebra courses. So this should be what they take in an introduction to algebra course. And what they need to do before they do this lesson, they need to already know how to plot points in the Cartesian plane. They need to be able to use the order of operations to simplify an expression. They have to be able to add and divide whole numbers. We're not dealing with decimals so much at this point. They have to be able to measure time using stopwatches, and they have to be able to order numbers from least to greatest.
In taking what we expect them to be able to do, we would like them to compute the mean, the median, and the mode based on definitions that we've given them, the run through, how to calculate it, and exactly what it is. Then we need them to actually be able to give the visual. The visual is an understanding based on what they get from the equation that they've worked out. So in providing the visual, they need to create a box and whisker plot or a box plot and a scatter plot.
Now, this will all correlate in them coming up with a real life scenario. In that real life scenario, they're going to have to take data that they found. So this might be messy data. It might have decimals, it might take them 3.75 minutes. And so they're going to input that data into Excel and then use the tool of Excel to compute mean, median, mode. And they'll be able to find all their statistical data from Excel. They'll also have to graphically represent the data by hand. You always want to back up and make sure that the computer data is correct. So by graphing out by hand, they'll get a generalization. Do they think there's a correlation between time spent waiting in line and the number of people in line? And then they'll have it backed up with the Excel data. And in the end, we need them to propose viable solutions to the queuing system, and they must have justifications. It's one thing to come up with just any solution. Oh yeah, just have the teacher deliver lunch. Oh, just give everybody free lunch. Or my student's favorite, make lunch half an hour longer. Okay, those aren't viable solutions we can use. But maybe it is to have an extra cashier at the lunch line. Or at our school, we have carts that sell lunch. So maybe moving a cart to the other side of school. And we'll have them come up with discussions like that.
So it's all about a procedure. We all follow procedures in our daily classes. What Anna and myself have designed is a 5-day lesson for 50-minute class periods. So if you're teaching block classes, you're going to need to adjust the time accordingly. But day 1 is going to serve as a mere introduction to statistics. What is a statistic? How do you work with it? And particularly, we're going to dive into mean, median, mode, maximum, and minimum. How are they going to use these things? What are these things? And it's just going to be a very basic, real life, try to bring it in. And to tie it together with real life examples, in California, most of our students have experienced Disneyland. And so we designed a worksheet based around wait times at Disneyland. Now notice these data sets go from maybe 5 to 6 points, something that's very small. It's not going to give them an accurate count of what the mean is, but it's going to give them enough numbers to actually go through and be able to calculate what an average is, how to find the median, what is a mode if there is any present.
And one thing we wanted to do, we want our students to be thinking critically. So at the end of this worksheet, we brought in our first critical thinking. We have them discuss what factors could have caused the longest wait times. Was it the ride shut down? Maybe somebody needed to have the ride paused because they were getting in a wheelchair, and so that extended the wait time. Or what caused the shortest wait times? Did the person surveyed have a fast pass? Was it an empty day at the park? What could have caused these things? Because in statistics, you always want to know why the data looks like it does. You don't just want to take it for being fact, because sometimes you have these outliers that cause skewness in the data.
So coming into day 2, we're going to be looking at the visual. So day 1 was all about the basics, getting them introduced into what statistics are and how to find these numbers. Day 2, we want to take it and to provide the visuals. The visuals are box plots and scatter plots. When I talk about box plots, they need to understand that it's broken down into quartiles and exactly what a quartile is. So how I chose to kind of explain it is you're going to need, the first step is to order your data from least to greatest. After ordering your data from least to greatest, find your median. That's one of the key definitions from the first day, so it needs to be carried over into the second. The second quartile is your median. So now that you have your median, you can look at the first half of the data set and the second half of the data set. Looking at the first half of the data set, you're going to take your median, and that's going to be known as your first quartile. You're then going to look from the median to the maximum. That's your second half of your data set. You're going to take the median of that. That becomes your third quartile. You then draw your box around your first and your third quartiles. That's your box. Now, let's figure out what the whiskers are. Well, you're going to extend the line from your first quartile to your minimum. That is known as your first whisker. You're going to extend your line from your third quartile to your maximum. That is known as your second whisker. So that's the box and whisker plots kind of in a nutshell. For scatter plots, Anna's going to go ahead and take that one.
Now, scatter plots are important when you have a wide spread of data. You want students to be able to see if there's a correlation. We always want to know in any kind of math and statistics, are our parameters related? Is wait time and number of people in line related? Is the cost of something and how long it takes to produce it related? Okay, this is important coming up with valid analysis of the data. So by doing the scatter plots, we're going to have students find if there's a positive correlation. So if it's from left to right, it's going up. Okay, we're seeing that there is a positive correlation. When one goes up, the other goes up. Negative correlation. When one goes up, the other goes down. Okay, they're negatively affecting each other. Or no correlation. If the data is all over the place and scattered everywhere, then clearly the two pieces of parameter are either not related or your data is bad. We'll also have them discuss outliers. So that's kind of what I was talking about before with the Disneyland wait times, what caused the longest and shortest wait times. Outliers happen when one piece doesn't fit that correlation. One piece is so far off from the line that something's got to be wrong with it, or that's what students would think. So we want them to discuss outliers, what could make them wrong, or what could make them accurate and have to be a consideration in your process. And at the end of the day, we're going to check out stopwatches to students. These stopwatches are so they can collect their own real-life data. We're going to have them go through the lunch line with those stopwatches and time how long it takes to get through that line. And we'll also have them do a tally to see how many people were in front of them in that lunch line.
So day 3, we're going to go in, we're going to actually take the visual to the next step. We're going to actually start using the computer to show these students, our students, what these statistics do, how to use it with a large data set. And so we're going to take place in the computer lab. With the computer lab on day 3, there's going to be some issues with the students in Excel, but that all being said and done, we all can handle that, I'm sure. But we need to take the data that they collected for homework. Hopefully they took their stopwatch and they did the assignment. And we're going to go through, and as they walk in, we're going to have 2 lists on the board. One for the amount of time that they waited in line, and one list for the number of people that were in line ahead of them. We're going to take that data, we're going to, when class begins, hopefully all the list is on the board, and we're going to actually input that into Excel. By inputting that into Excel, we can actually take 30 points. And if you wanted to, you could actually take more as the day goes on, your other periods, and put them into one big spreadsheet. And the more data you have, the more accurate things become. But we're going to actually go ahead and compute the mean, the median, the mode for larger sets of data.
And we're also going to have them still do a scatter plot by hand because, again, we want them to confirm that the data that's coming out of the computer matches what they think from a graph. So we're still going to have them bring in that self-analysis on top of the computer analysis. Now, our mentor was kind enough to give us a little video for our students on queuing, why it's important to him in his job, and why it's important to students to know. So we're going to bring that up for you right now. One second, we are having some technical difficulties.
I'm a NASA engineer at the Kennedy Space Center in Florida. The types of modeling and simulation and analysis that I do is about system performance analysis, and that involves queuing systems. Queuing systems are everywhere. Imagine anywhere you stand in line waiting for something, like in a grocery store, a theme park, or even in your school cafeteria. Queuing systems are also used in industry, in assembly lines, including storage areas for things that are going through their system, where tracking of these lines is necessary to ensure that the system is efficient. Efficiency is all about money, that is saved or lost, and also about customer satisfaction. Queuing systems in NASA at the Kennedy Space Center have to do with the processing of spaceflight hardware, stacking them into launch vehicles and launching the vehicle at the pad. The only difference between our queuing systems and the ones in your world is really about the cost involved and a bit about the hazards also. The cost of spaceflight hardware, for instance, can range from the thousands of dollars to millions of dollars and even into the billions of dollars. The Space Shuttle orbiter Atlantis that just landed for the last time in the program last week costs over $3 billion. Would you want that expensive a hardware waiting in a queue? For that matter, do you really enjoy waiting in a queue at a theme park or in your school cafeteria? Wouldn't you rather be riding the ride or eating in your cafeteria? In all processing systems, from the processing of spaceflight hardware to getting students fed in the cafeteria, either way, the hardware or the students enter the system and go through a process. That is, hardware arrives at KSC, or students that go through the doors at the cafeteria, and the process that they go through takes time. If the system isn't exactly perfect, that is, if the processes of the system do not satisfy the customers exactly when they want that service done, then lines form. These lines are called queues. Depending on how long the process takes and how many things are demanding that particular service, the overall time spent in the system varies. A couple of ways to measure the effectiveness of a given system is in the overall amount of time something spends in the system, and in particular, how long something waits to be served in that given system. For complex systems, there can be many, many processes in serial or in parallel, each with their own queue. So you could end up spending time waiting more than one time. Queues also have a variety of characteristics that affect how long you spend in the system, such as how long, or the size of the queue, and the protocol for the queue. And by protocol, we mean, is it a first in, first out queue? Is it last in, first out? Or is it a priority queue? Now think about a priority queuing system. Imagine if you could, with either good behavior or doing a good deed, that you could get a pass to the front of your cafeteria line. These ideas and more need to be considered to make things we do in our everyday life better. Your teachers are going to explain how to understand these concepts and what makes them good or bad or even just average. It is these same concepts that we use here at NASA to understand how well our space systems processes work. These also can be applied to your everyday life.
Now, one thing that was important about that presentation is the fact that it's under 5 minutes. With our students, we know it's easy for them to lose their attention. So we want to be changing things up. Yeah, really. And so we want to change it up on a regular basis. We don't want them focused watching a video for too long, or they might get distracted. We want to constantly be changing the activity. So on day 4, we're going to have students look at the larger sets of data a little closer. We already told you we were inputting them. This is the day we actually analyze them.
So in analyzing them, we want to go ahead, we want to take that large data set, and we've talked about them finding the mean, the median, the mode, but they need to find the maximum, the minimum, and then we want to actually discuss in Excel how to go ahead and put a visual to it, because we can create that box plot or that scatter plot, and we can talk about it. That's going to lead into our discussion about how they would fix the line queuing problem. Again, we want those viable solutions, the solutions of, oh, you could add another cashier, or maybe break that line into 2 lines and have 2 cashiers deal with 2 lines, or you could actually spread carts across the campus. These types of things are things that need to be discussed and lead into day 5.
And the important thing on day 5 is we bring it back home again. Okay, first we want to make sure the students have an opportunity to share their ideas with one another. We don't want this to be an individual environment. We want it to be a group collaboration. And so we want the students discussing the different solutions and have them vote, decide what they think the best solution is, what they think would really work. And depending on your school and how open they are to ideas, maybe have them write a proposal and give it to the administration, see what happens. And finally, we want to go back and again review what was covered. You never want to end a unit without going back and making sure they remember what was on day 1. 5 days is a lot of time to forget stuff. So we want to go back. What is mean, median, mode again, guys? What's the formula for these equations? We want to make sure they understand that. And so we want to wrap it up on the end with checking for that understanding with a final quiz. We want to be, as teachers, be able to know, did they understand the concept? Or do we need to go back and reteach something? Okay, we want to always wrap up and be able to prove, okay, they understood mean and median, but they still really struggle with that concept of mode. They don't understand that sometimes there's not a mode. Different concepts like that, and that way we can focus on what maybe needs to be brought back up on day 6.
So in looking at this, there needs to be student accountability as well as teacher accountability. So we need to implement assessments throughout this unit, through any unit. We all know this, we've all been trained in this. So in doing this, for these various forms of assessment, we need to look at problem set worksheets, which give us the analysis of can they actually go through the computations by hand. We need to look at graphing worksheets that do they understand how to provide the visual when given the data. And lastly, their ability to articulate and propose a plausible solution. Was it just something that was so outlandish that they are missing the point behind the statistics analysis and they don't understand what the visual is saying, so they're just going to come up with whatever they want to come up with, or are they actually understanding it? And then we need some kind of formal assessment, something that has a definite right or wrong answer, and we can actually go through and find out what do we need to reteach, and that's through the form of a written assessment, which are actually spread throughout the unit as well, and in conclusion with that final culminating quiz at the end of the unit.
And then finally, we need to look at what's next. After this amazing experience, what are we going to be doing? And so the easiest one to come up with is we're going to go back and we're going to teach this in our pre-algebra classes, and it's going to help prepare them for their KC, which is their high school exit exam in California. Gives them that introduction to statistics that they maybe wouldn't have all the time. And we're also going to be creating a math club at our high school. They haven't had one in the time we've been there. And so we're going to use that to bring in some of the concepts that maybe don't relate to the pre-algebra I teach, but maybe it'd relate to the calculus students. Be able to show them some of the simulations used and the calculus involved in creating those trajectories. Or we'll bring in moon rocks for those science kids. Let them see what's the composition of a moon rock. And bring in those different concepts that cover science and math and engineering, but maybe not to my immediate class I'm teaching.
And don't forget, we need to spread the word. We all need to go back to our schools and talk to our departments, talk to our faculty, encourage them to look into these opportunities. Look at the teacher credentialing programs that we've gone to. Go back and talk to those courses at our universities. Go talk to your specific area at the university. I know for myself, I'm going to go talk to the math department at Cal State San Bernardino, where I went. And the regional newspaper is a good way to actually pick up an article. I know we were fortunate enough to have the San Bernardino County Sun cover us while we were out here, and that's going to reach a large audience. But there's things that we can all think about, and I know that we've already heard them, but things such as conferences. I know Anna and Ramona have come up with a couple conferences, and there's more that's still in the works. But we need to encourage people to go ahead and take these opportunities to look into them, because I know just specifically for the Bloomington group, we all thought that this wasn't a possibility for us. We kind of tend to limit ourselves, and this is a dream come true. And I think on behalf of Anna and myself, we just want to say thank you so much to our mentors, to Les, to Lisa, to Lena. Even the group that's here, the other teachers, just that conversation, that bonding. So a huge thank you so much from the bottom of our hearts for this experience.
Thank you, guys. And that's it.